Right now, let's focus on water waves. Water waves occur at the air-sea interface. It is typically generated offshore in the ocean when storm or wind effect acts on the surface of the water. The disturbance caused the wave to be generated, and it started to propagate outwards from its source area, carrying the energy which is being transferred uh, along the direction of propagation, which of course eventually arrives at the coastal region. Now, as the waves propagate, there will be little wave dissipation, but when it arrives at the coastal region, the energy dissipation increases due to the interaction with the seabed and also interaction with the shoreline. The dissipation of wave energy as they arrive at the coastal area plays a very important part in how the coastal shoreline or beaches are being formed. These are the common types of water waves that can be observed in the coastal region, from the smallest vessel-generated waves with wave height less than 1 meter typically, and wave period not more than 3 seconds, to the more common wind-generated waves, which can have wave period up to 30 seconds and wave height as large as 6 meter during an extreme storm event, and to the longest wave known as tide, which have a wave period of 12 or 24 hours generally, uh, which means that the high tide is basically the arrival of the wave, and it actually arrive and depart and arrive again in a period of 12 hours. And the height of tides varies depending on location along the coastline. Um, it can be low, but can also go up to 6 meter along the shore. But of course, the height of tides varies very slowly and is different from wind waves, which have a short period. So if you have a wind wave that has a 6 meter wave height, it is a very uh, violent and intense wave action. But whereas for the tide, it is only observed as the uh, gradual and steady rise or fall of the wave only. Of course, we also have solitary waves such as a tsunami, which has a wave period between typically 5 minutes to 1 hour. They may have a very limited wave height offshore, but once it arrives at the coastline, it is amplified, and it can actually has a much larger wave height, which can be destructive. Now we also have internal wave, meaning wave between the uh, saline seawater and the freshwater uh, discharge from the river. But this is not our main focus here for the purpose of this lecture. This slide here shows the typical wave energy spectrum. Now, if we look at the horizontal axis, we have the frequency. If we inverse the frequency, we have the wave period. The larger the wave period, the lower the frequency. The smaller the wave period, the higher the wave frequency. So if you recall our table just now, example of vessel generated wave, wave with small wave period, which means they are in this region over here, high frequency, whereas for tides, the wave period can be up to 12 or 24 hours. They are what we know as the low frequency wave. Now, each of these different spectrum of wave, they may be generated by different disturbing force. So here we see the primary disturbing force. So the wave, the tides are typically generated due to the celestial movement of the Earth, the Sun, and the Moon. So these are the disturbing force that generates the wave. Whereas in this region over here, the primary disturbing force is the wind. We also have primary disturbing force here due to storm, due to tsunami. Now, once the waves are generated by these disturbing forces, they will be restored in the sense that once the water level at the surface of the sea changes, it tends to want to return to its original position, and that is where the restoring force acts. So the displacement of the water surface typically are restored by gravity action. So you can imagine if the wave goes up, it is the gravity action that causes it to come back down again. And as a result of that, it goes into an orbitary motion. So gravity is the most prominent restoring force in wave motion. But for a longer wave period, Coriolis force is the primary restoring force. Coriolis force is the force due to the rotation of the Earth that tend to bring the wave back down to its equilibrium position. So if we look at this wave energy spectrum, then we notice that in the coastal region, most of the wave are in this category. There are less wave with very small wave period, but there are quite some wave with a longer wave period. So this wave energy spectrum show to us the distribution of the different type of wave with different wave period or wave frequency as typically observed in the coastal region. So we mentioned that gravity force is the principal restoring force, and made up large amount of the total wave energy. Typically applies to wave period between 0 to 30 seconds and is most important in coastal engineering problems.